Hello everyone, this is Hari Venkatraman, and in this video we will be creating the class diagram for this ATM transaction system project in C++. So in the previous video we created the use case diagram. Now we are taking this a step further by creating the class diagram. So for that we will go to model, add diagram, and instead of use case diagram you will select class diagram. So a class diagram is represented using rectangles where each rectangle is a class, and each class will have attributes and functions or operations, and these classes will be connected by the associations, the respective associations. So it can either be a composition. The composition is like the include in the use case diagram where one thing cannot exist without another. A dependency or generalization, both of these are like an inheritance. Aggregation is where something is like all accumulated into another class. So like for example, students are accumulated into one classroom, so that's aggregation. So let's start. So first we will create a bank class. So first we have, in the use case diagram, we had the bank as an actor. Here the bank as is a class. So here we will click add attribute. So attributes are like variables or identifiers in a class or instance variables. So each bank, when you logically think of a bank, each bank has its own code, area code, or tracking code that is used to identify this bank uniquely from other bank or branches of this bank even. And then you have the address, so that will be another attribute. So these two can be represented using atomic data types. So now we have the functions, operations. So we have the operations. So first operation will be manages. So basically it's just extending this one level higher in terms of detail. So to add, just right click on the class, just add. You can select either operation or attribute. So here we'll just add one more operation. So the bank class is created, and now let's create another class called this. Class diagram would parallel this use case diagram, but it's slightly more involved with the attributes and the operations or functions. So first we need, in the previous video we mentioned that there must be a unique location to identify this ATM, and there must be a unique tracking ID. So that would be the managed by. So these are the two attributes. Now we have two operations. Identifies the type of transaction, and transactions is we will have another. So this function decides which transaction that is performed. So in terms of associating the bank with an ATM info, see, a bank can have multiple ATM branches. So this would be, so we will first have this association, and usually when we're creating class diagrams we would talk about multiplicities or cardinalities. One to many, zero to many, zero to one, one to one, many to many, etc, etc. So for that you could just go to text here and click anywhere you want, text. So one bank can have, so we are starting with one on the bank side, and then we go here to the right hand side and we click. So one bank can have many ATMs. This sounds logically correct, because one bank has many ATMs, of course, obviously. Now let's create the customer class. This is the most important class of this project. So customer. So each customer has their own name, address, and date of birth. So name, and then address, where they live, their personal details, and their date of birth. These will all be stored inside a database, and we will have an operation that detects which type of account they currently own, and it will retrieve their account number. So a customer, so this is where the composition comes to play. So the reason why I've put a composition symbol here is because without this bank, the customer won't exist, because the customer is a customer of the bank because the bank exists. That's self-explanatory. So in this, the cardinality should be obvious because banks can have millions and billions of customers. So one bank can have one or many customers. Yeah, one bank can have one or many customers. So that's the cardinality here. Next is the debit card class. So we're just converting that use case diagram into individual classes, each with their own identifiers, instance variables, and methods. So debit card. Now the debit card will have first the card number as an attribute. See, if you just know the, like I said in the previous video, if you have a logical structure of your project, you can just expand to any height. You can just expand it to any depth you want before proceeding with the coding or whatever project you want to model as a UML diagram. UML diagrams really help to start your project, and they successfully enhance the levels to where you will feel confident to start and not feel overwhelmed by the content. So this is owned by variable connects to the customer. So one or many customers can have one or many debit cards because it's it's a commutative relationship. Many customers can have many debit. It's a many to many relationship. So for that, we will first create the association between debit card and customer, and then for text we will go to this side. So the customer can have, each customer can only have at maximum one debit card, but many customers can have many debit cards collectively. So one customer can have only one debit card, one-to-one relationship. So now we have now let's create the account class, which is also a pillar for this project for an ATM transaction system. So we have account, and the account will have only two attributes. That's it. No operations, because the operations are performed by the transaction and the ATM info on the debit card. So first we have the attribute of type, either a current account or a savings account, and then we have another attribute named owner, which connects to the customer via a variable. Now for debit card, let's just add one more operation. So like this, you can just like add whatever attributes you want, as long as they make logical sense, they are going to work for your project. So access. Next, we must connect the debit card class to the account. So that is also a one-to-one relationship, because customer can have one debit card per account. So we will go and draw this line, and here this will be 1 and 1. So now in this use case diagram, account has subtypes, current account and savings account. So here accounts, current account and savings account will be separate classes but connected by a generalization. This is the inheritance concept in object-oriented programming. So first, let's create the current account class, current account, and here we will have, inside this only we will have the account number, because the account class determines the type of the account and each specific account will have its own account number and balance, the account balance that will be checked upon when withdrawing or any any other transaction that involves uh, altering of the money balance. And then we have two operations, debit and credit. That's self-explanatory. Next, and credit. Okay, so now we will, the way we represent this is by generalization, by this arrow. So like this is the format of generally creating star UML diagrams, a class diagram in star UML. Just drag and drop a class, and using this use case diagram, just use this use case diagram as a template with the include and extend. The extend would translate to the generalization, and the include will translate to the composition and the aggregation, and the actors will also transform into classes as well as use cases, and each of those classes will have identifiers or attributes or variables or whatever you want to call them, and functions or methods. So this is the basic format of creating a class diagram in star UML. Thank you for watching. I'm Hari Venkatraman. Thank you.